Our focus for today is going to be similar to what we did Friday. On Friday, we started to work with equations that don't just have one solution, that have infinite solutions. And we identified a few things. In your DOL, a lot of you mentioned that I could tell the first thing I could see if I was trying to determine if there was an infinite number of solutions is if my coefficient was the same on both sides. Okay, and on some of your papers, we may have wrote like there's some more stuff that comes along with that, which we're going to talk about today. So here are three students. We have Yadi, Alyssa, and David. Okay, and they were each given an equation to solve, and we're going to figure out whose equation has one solution, whose equation has infinite solutions, and whose equation has no solution. So there is the possibility that an equation could have no solution. We're going to see how that happens. Okay. So let's first look at Yadi's equation. Top equation, 2 parentheses x plus 10, close parentheses, minus 17 equals 5 plus 2x minus 2. Okay, that's her equation. What do you notice about both sides? Can I see anything right away, or do I need to start to simplify? And if I do simplify, what do you get when you simplify both sides?
Okay, so if you look at the coefficients, you can see that there is going to be a 2x. So you can just X that off of your list of what you can find wrong with the equation.
Okay, so if I simplify the left side of my equation and I distribute, I will get a coefficient. I'll have 2x plus what?
10. 20. And then you get 3.
Okay, what can I do now? Now, is it enough? Could I look at this and say, infinite number of solutions, I know it, I'm done? Do you want to make that claim? I see that they have the same coefficient, so it has to be infinite solutions, I'm done.
Oh, no.
We don't want to make that claim yet. This may signal something to you, but there's a few options here that we need to explore. How can I simplify this further? Okay.
20 minus 17.
Good, I can combine these like terms, 20 minus 17 is plus 3. And how about on the other side? Go ahead.
5 minus 2.
5 and the negative 2 gives me plus 3. What do you notice now? So are we fully simplified? Yeah, we fully simplified. We can't combine our like terms on the left side of the equation any more than we already have. We can't combine on the right side of the equation any more than we already have. Make sure you're following along on the board so you understand what's going on, because there's certain things you want to look for. Okay? At this point, what do you know about this equation? It has many solutions. And how do we know that for sure?
Because your coefficients are identical.
So my coefficients are identical, but what else? We want to go a step further now.
And your two terms are identical.
Okay, the expressions on both sides, the two terms on the left side of the equation, the two terms on the right side of the equation are identical. Whatever number I substitute in, think about any number, and in your head try to do it really quick. Any number. They will all work, because no matter what number you substitute in on both sides of the equation, you're multiplying that number by 2, and then you're adding 3. So any number you use, whether it's a negative number, a positive number, a fraction, a decimal, you're still going to have an infinite number of solutions because they all will work. If I take away 2x from both sides, what does my equation look like then? If I take away 2x from both sides, what does my equation look like then? Yeah, if I take 2x away, then my equation is 3 equals 3. What does that mean? It means that both sides are equal. It means that this is a true statement. That means it's true. And this, some students want to say that 3 equals 3, there's no solution. That's actually the opposite. Any solution is a solution, because no matter what I do in this scenario, 3 will always equal 3. So we explored that on Friday. We saw what it looked like to have an equation with multiple solutions. Let's look at Alyssa's equation, the second one. How is hers different than the first? How is the second equation different from the first? Just look at it. If you want to start to simplify it, you can. But while looking, what do you see that's different? What do we see that's different? You can start to simplify. Oh, I hurt my knee. That hurts so bad. What do we see that's different? What do we see that's similar? Go ahead.
On both sides there's an x.
Okay, so we have variables on both sides. Let's start to simplify it. If I simplify, bless you, on the left side of the equation, what do I have when I simplify? What like terms can I combine? Rahelia.
5x or 3x.
And what kind of 3x is that?
Negative.
It's a negative, so how many x do I have? 2x. How about the right side?
You can distribute 2 to x and 3.
So what's my second term going to be here?
6.
Now what?
I
I can combine my 6 and negative 5, and what would I get there? 1. So how are Alyssa and now let's show this simplified. How are these two equations similar?
Both variables the same numbers.
Good, okay, so for both equations, the variables are the same on both sides. See, in the top we have 2x on the left, 2x on the right. Here we have 2x on the left, 2x on the right. What's different? Use the word, you have it.
Constant.
The constant. What's different about the constant in Alyssa's equation? So on one side it's plus 3, and on the other side it's plus 1. And in Yadi's we know they're identical. What do we think about that?
There's only one solution.
We think there's one solution? Okay, we're going to actually explore that a little bit further in a minute. Let's look at David's. If we simplify David's, we would get 2x. Simplify the rest for me. What do I have? Minus 6 plus 9, which would be
Equals 3.
equals what?
4.
Are the variables the same on both sides?
No.
Are the constants the same on both sides?
No.
Solve it.
Ooh.
What would I do to solve?
Subtract x.
Okay, I can take x away from this side. So I have x plus 3 equals 4. Now what? Now I can take 3 away. So x equals 1. Very good. Okay, so now let's start to look. We're going to go back to Yadi's equation. If I simplify this, we knew that we had 2x plus 3 equals 2x plus 3. Both sides are identical. Okay. The variables and the constants, and this is the key. If you want to start writing down what's in red, these are the 3 differences between there being one solution.
Attention students and staff. At this time we'll be conducting a hall sweep. All students, please report to the main office. All teachers, shut their door. Do not allow entry into the classroom. Once again, all students in the hallway, please report to the main office.
So this scenario here shows on a scale infinite solutions. The variable and the constant are the same on both sides. No matter what value for x you choose, the solution will always work. Every solution works. If you want to start to identify if you want to write down ways to identify the three differences, highlighted in red would be the things to focus on. Okay, so we have here the variables and the constants are the same on both sides. No matter what value you choose for x, the equation will always be true. If x is 0, if x is 10, if x is -3, always going to be the same. Same variable, same constant. Same variable, same constant. That's really what I would just focus on. Same variable, same constant, identical. Infinite solutions. You'll have an opportunity to write some of this again. So Alyssa's equation is a little bit different. When we simplified Alyssa's, we had 2x plus 3 equals 2x plus 1. Is there any way to balance Alyssa's scale? Take away 2x. Okay, if I take away 2x here, and then I take away 2x here, I'm left with 3 equals 1. Is that possible?
No.
No. So what do you think in terms of solution? Is there any other way I can try to balance this? Is there anything I could possibly do to balance the scale? No, there's nothing I can do. In this scenario, and this would be no solution. And that's why for those of you on Friday, when we were talking about the difference between one solution and infinite solutions, it was enough on Friday for you to say the variables were the same on both sides. But notice now the difference. The variables are the same on both sides here. I'm multiplying a number by the same number on both sides. The difference is the constants are different. There is no possible number that I can multiply by 2 that would be the same if I added 1 to that number or if I added 3. Okay? So in this scenario, when there's no solution, same variable, but the constants are different. Again, if you're a note taker, which you may, none of you are really writing anything down, highlighted in red would be what you would want to focus on. Same variable, constants are different. There is no value for x that would be true. And I know I slanted the scale just for dramatic effect, but that would never balance, ever. If I wanted to subtract 1 from each side, it would be 2x plus 2 equals 2x. That's not possible, right? This is the same number, but on this side I'm adding 2, and on this side I'm doing nothing. So there's just no way. The left side is always going to be 2 numbers.
We're all clear with the Hall sweep, all clear with the Hall sweep. Students are allowed back in with the proper documentation. Thank you.
So same variable but different constant, there's never going to be a solution. And then in this scenario, in David's, that's what we've been working with. Different variable. It doesn't really matter about the constant. The variable being different, we will have a solution. There will be one. So if the variable terms are different, then there will be a solution. Worst case scenario, if you don't remember these tiny things, okay, same variable, same constant, they're infinite. Same variable but different constant, no solution. Worst case scenario, simplify to solve. If you simplify and you go to solve, you will see what's going on. So what do you notice about the balance? The balance and the actual scale? What do you notice in the 3 models? Let's just talk about them for a second. So this one was Yadi's. This is Alyssa. And this is David. What do we notice?
That if there's an answer, your scale will be balanced.
That if there is a solution, whether it's 1, it's a really great point, 1 or infinite, the sides will be balanced if you're visually looking at it. Good. What else can you see from this?
I noticed that it's 2x plus 3 on the left side of all.
So all of these actually had 2x plus 3 on the left side. Good. The right sides are a little bit different, just to highlight the differences in the equations. Anything else we notice? If you showed these, I know we're not really, you won't have like a scale, but if the scale cannot balance, like Alyssa's, there will never be a solution. There's nothing we could do that would balance that scale. We already answered that. So in your groups, we're going to solve these two. You can do them in your binder, you don't have to do them on your whiteboard, but we want to solve these and talk about the solutions that you came up with as a group. They're not all, we're dealing now with one solution, no solutions, or infinite solutions. So there may be a point in time during your solving process that you see whether it's one solution, no solutions, or many. So start to solve in your notebook and come together as a small table and talk about what you're finding. If you know that there's one solution, find the solution. If at any point in time you know there is no solution, from there you can stop. And if at any point in time you know there's infinite, from there you could also stop, because you know at that point what the solutions would be. So talk amongst your tables now and see what you found. Our first big question is there a solution? Like, is there one solution, infinite solutions, or is there no way to solve it?
I said that the first one, but yeah, I said there's no solution to Monday. What did you get, Emily?
All right, who wants to share what their group was talking about in terms of comparing these equations? What did you notice as you were solving? Because you're not going to know on a test if there's one solution, no solutions, or many. You're just going to be asked to solve it. And the question's going to say solve for x. And some students get really alarmed when they see solve for x and then they can't get a solution. A lot of students are like, well, if the teacher said to solve for x, there has to be a solution, so I have to make up something. Right? Some of them intentionally are going to be no solution because that's part of the learning process for this unit. What did we notice within our groups, or what did we talk about within our groups that maybe you understand or understood on your own? What do you think?
For the first one,
Okay.
there was one solution.
How did you know that, or when did you know that?
After I simplified it, so you have 6x and
So once you simplified it, what did you see?
you can see that your variables were very different.
Good. So once you simplify, at this point, you should see that your variables are different. well, the coefficient, I should say. The variables are still x. But on one side, I'm multiplying x by 6, and on the other side, I'm multiplying x by 8. Very different operations there. They're not identical, which means what? I know how many solutions will there be.
One.
There will be one. From here, how would you solve? Look at someone else that hasn't. Giselle, what would you do to solve?
I don't know how to say, but I subtracted 6x, 6 and 6x from all.
Good. You subtracted 6x from there, and then 6x from 8x. Good. So that's gone. We have 34 equals 2x plus 12. Now what can I do? Go ahead. I can subtract 12 from both sides. So I have 22 equals 2x. Solution? Divide both sides by 2, so x is 11. Very good. And again, you could have seen after that first distributive property that you have one solution because the variable, the coefficient with the variable was different. Okay. How about the next one? What did your table talk about in terms of what gave it away? What told you whether there was one solution, no solutions, or any? What did you all come up with? Go ahead.
That when the 4 got multiplied by the 4, like when the 4 multiplies by the 2x, we knew it was 8x.
So at this point, there's a chance that it could be an infinite number of solutions because here I have 8x plus 6. So in terms of criteria, variable coefficient being identical and constant being identical, coefficient variable are identical right now. Or coefficient variable being identical. Yeah. Okay. But then what happens?
Then we multiply the 4 by 3, we get 12.
When we distribute here, we get 12. Problem? Big problem. How many solutions? 0. No solutions. And here's the thing. Do not put, and students do this all the time. Students do that. That means that x would be 0. If I substitute a 0 in, 6 does not equal 12. You can't say x equals 0. You would just write no solution. Okay, and I'm so glad that someone actually just said there were 0 solutions. Because that's what students have thought in the past. Well, there's 0 solutions, they just put 0. 0 is an actual number, so that would be a solution. You can't put that. Just write no solution. And again, the reason we know that, while our 8x now is identical, the constant, I can't multiply a number by 8 and get the same result when I add 6 to it, and then when I add 12 to it. It doesn't make sense. The right side of my equation will always be 6 units greater than the side on the left because of what we did here. Any questions about the differences between one solution, no solutions, and many? Because now what you're going to do is you're going to be just given problems from this point forward. And you're going to be asked to just solve. So now you'll be able to find one solution, but then you should also be able to identify if there's no solutions or if there are infinite solutions. Okay, for your DOL on the top, explain, and you're actually not going to do this in detail. We already explained on Friday the difference for infinite and one solution. For your DOL today, I'm going to answer that question in just 1 second. For your DOL today, explain how you would know if there's no solution. And you can do this on the DOL sheet that we gave back to you. That was going to be your question, right? Yeah, you can use that same form. Now, when you are done, at this point, you are free to do any Learning Target 1 or 2 assignment. Learning Target 3, we're actually doing it at the same time because Learning Target 3 is that you could explain the difference between one